गुड इवनिंग टू एवरीवन। क्या आप मुझे सुन सकते हैं? प्लीज राइट इन द चैट बॉक्स। क्या आप मेरी आवाज सुन सकते हैं? दैट्स गुड। सो गुड इवनिंग टू एवरीवन। So this is the 8th standard mathematics class. So I will present my screen. So आप बता सकते हैं कि आप मेरी स्क्रीन देख सकते हैं? Please write in the chat box. That's good. So let's start with our class. So we left, I think, about indirect or inverse variation. So I will just give a recap about what we learned last time. We started with the variation. So first we have seen about direct variation or direct variation and inverse variation. So there are two things which we learned in last lecture. हमने लास्ट लेक्चर में दो चीजें देखी थी। एक ये है कि डायरेक्ट वेरिएशन और सेकंड है इनवर्स वेरिएशन। सो डायरेक्ट वेरिएशन में हमें पता है कि दो वेरिएबल होते हैं तो हाउ दे आर रिलेटेड। सो दिस इज डायरेक्ट वेरिएशन। और इनवर्स वेरिएशन में x is proportional to 1/y. Okay. This is the symbolic representation of direct variation, whereas for inverse variation, this is the symbolic relationship. So if we want to transform, अगर हमें इसे equation format में transform करना है तो हम कैसे लिखते हैं? So we'll start with for direct variation, x is equal to ky, or for inverse variation, it is x is equal to k/y. So इस प्रकार से हमने लास्ट लेक्चर में पढ़ा था. So let's move to the next thing. So hopefully आप मेरी आवाज बराबर से सुन सकते हैं, right? If you have any issue, please let me know through the chat box. We solved some problems. हमने कुछ प्रॉब्लम भी सॉल्व किए थे. So let's try to work on some more problems to understand better about this concept, like direct variation and inverse variation. So we will start with this is practice set 7.2. So we will start with this. So there are like the information about number of workers and number of days to complete a given work. So एक प्रोजेक्ट है या एक काम है जिसे कंप्लीट करने के लिए कितने वर्कर्स चाहिए और कितने डेज लगेंगे, ये हमें दिया गया है और उसके अनुसार हमें वेरी करना है. सो दिस इज वेरी इंपॉर्टेंट फॉर एनी प्रोजेक्ट. प्रोजेक्ट प्लानिंग के लिए ये इस प्रकार के जो डायरेक्ट वेरिएशन और इनवर्स वेरिएशन जो भी हमने पढ़ा है, हाउ दिस इज यूजफुल, हमें ये कैसे एडवांटेजेस होती है, ये हम यहाँ देख सकते हैं. जैसे अभी एक प्रोजेक्ट के लिए यहाँ लिखा गया है कि नंबर ऑफ वर्कर्स आर लाइक 30 एंड दे कंप्लीट दिस वर्क इन 6 days. सो हमारे पास 30 वर्कर्स हैं और वो 6 दिन में ये काम कंप्लीट कर देते हैं. सो अगर हमें इसका सपोज अभी हमें पता है कि दिस इज प्रॉब्लम ऑफ इनवर्स वेरिएशन. सो 30 into 6 is 180 degree, right? 30 into 6 is 180 degree. 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 180 de और सिमिलरली अगर हम नंबर ऑफ वर्कर्स कम कर देते हैं लाइक 20, देन नंबर ऑफ डेज इंक्रीज हो जाता है, दैट इज इक्वल टू 180 अगेन. सो हम देख सकते हैं कि नंबर ऑफ वर्कर इनटू नंबर ऑफ डेज ऑलवेज रिमेन्स कांस्टेंट फॉर एनी प्रोजेक्ट. सो इस प्रकार से अगर हम ये काम 12 डेज में कंप्लीट करना चाहते हैं, देन व्हाट विल बी द वैल्यू ऑफ नंबर ऑफ वर्कर्स. सो यहाँ क्या होगा, कैन यू राइट इन द चैट बॉक्स? सिंपल मल्टीप्लिकेशंस का प्रॉब्लम है ये. सो यहाँ number of workers into number of days should be equal to 180, right? Hence कितने आदमी होने चाहिए, कितने नंबर ऑफ वर्कर होने चाहिए यहाँ? So this is 180 divided by 12. So the value should be 15. Okay. And for the next thing, what is the value of number of days? If number of workers are 10, how many days may be required? So 18 days. That's correct. Or number again, yeah, for 36 days. If we want to complete this project in 36 days, then how many workers are required? If number of days are 36, then how many number of workers are required? Okay, 5. That's correct. So 5 is the answer. So हमने यहाँ एक देखा कि दोनों जो संख्याएं हैं या दोनों जो वेरिएबल हैं वो इस प्रकार से कोरिलेटेड है कि अगर नंबर ऑफ वर्कर्स इंक्रीज हो जाते हैं तो नंबर ऑफ डेज कम हो जाते हैं. सो आप अभी इससे एक मतलब आप एक सोच सकते हैं एक कि आप अगर आगे जाके किसी प्रोजेक्ट को मैनेज कर रहे हैं तो इस प्रोजेक्ट में आपको पता है कि टोटली हमें ये प्रोजेक्ट कितने दिन में कंप्लीट करना है और इसके लिए कितने रिसोर्सेस वगैरह लगेंगे. सो इसके अनुसार हम प्लानिंग कर सकते हैं, राइट? सो अगर हमें वो प्रोजेक्ट 18 डेज में ही कंप्लीट करना है तो वी नीड 10 वर्कर्स, राइट? बट यहाँ और एक चीज हमें देखनी पड़ेगी जो हमारे ये दिस इज द प्रॉब्लम ऑफ और क्लासिक एग्जांपल ऑफ inverse variation. So another thing is like salary, right? Salary. So salary is example of direct variation, right? So उसमें क्या होगा कि अगर हम नंबर ऑफ वर्कर्स बढ़ाएंगे तो सैलरी भी इंक्रीज होगी, राइट? सो इस प्रकार से डायरेक्ट वेरिएशन और इनवर्स वेरिएशन ये हमें यूजफुल होते हैं किसी भी प्रोजेक्ट को मैनेज करने के लिए. सो इस प्रकार से हमने देख लिया कि हाउ दिस डायरेक्ट वेरिएशन एंड इनवर्स वेरिएशन इज यूजफुल इन एनी प्रोजेक्ट मैनेजमेंट. ये तो मैं आपको एक एग्जांपल दे रहा हूँ. ये एग्जांपल्स आप फिर आप अलग अलग जगह भी अलग अलग एप्लीकेशंस के लिए यूज कर सकते हैं. सो आई एम जस्ट टेलिंग यू गाइस दैट please understand the concept of direct and inverse variation, so it will be helpful for you guys. Let's move further. So find constant of variation and write the equation of variation for every example given below. So I think it is very straightforward. You can write it down, and I don't think it is very difficult, but we will try to solve this problem. This seems to be some interesting. So what will be the constant of variation here? Okay, so S is inversely proportional to 1 by t square. So they have given S is equal to 4 and t is equal to 5. So S is equal to k by t square, that is in equation form. So S into t square is equal to k. Okay, so S is given as 4 and t square as 5 square. So what is the answer? So answer comes as 100. Okay, so this way we can uh, carry out the calculations and get the constant for the variation. So similarly, can you try this problem and can you give me the answer in the chat box? X is inversely proportional to root of y, and if x is 15 and y is 9, then what is the constant of variation? So here they have written that x is inversely proportional to root of y, and if x is 15 then y is 9, then what is constant of variation? Okay, so here we can see that x is inversely proportional to root of y. X is equal to k divided by root of y. Hence x into root of y is equal to k. And if we write down the values given from the problem, 15 into root of 9 is equal to k. So we can calculate, and many students has given right answer. So this is 45. That's correct. So hopefully you understood this uh, problem, or you understood the concept of inverse variation. Let's try to solve another problem here. So the boxes are filled with apples in a heap. Okay, if 24 apples are put in a box, then 27 boxes are needed. So this is another example. Then if we want to ship, if you are the distributor for Apple, suppose, then you have to manage the Apple boxes. Then how will you carry out? So so that this is another example where we can use this inverse variation for project management. So let's see how they have how to use such type of things. So if 24 apples are put in a box, then 27 boxes are needed. Okay, and if 36 apples are filled in a box, how many boxes will be needed? So here we will take number of apples is A, number of apples. Okay, and we will put boxes as a B at number of boxes. Okay, so what is the relation? is here like A is inversely proportional to P. So if we write in the equation format, it will become A is equal to K by P. So A into B is equal to K. So they have given first problem like 24 apples and number of boxes are 27. Then what is the value of K? Can you write in the chat box? What is the constant here? Why answer 48 is coming here? So we want constant of variation here. So constant of variation 24 apples into 27 boxes, right? So 24 into 27. So constant of variation is 648. That's correct. Okay. So now if we want to calculate the number of boxes for 36 apples, right? So they have given the 36 apples. So we will change the color for that. So they have given the 36 apples. So if we go by 648 as a constant, okay, A into B. So A is 36, 36 into B is equal to 648. So how many boxes are required? Please write in the chat box. How many boxes are required then? Can you write in the chat box? So there are 36 apples are filled in one box. Then how many total boxes are required? Yes, that's correct. So total number of boxes are 18. Okay. So these are the ways to solve such type of simple problems in daily life using the inverse variation. So uh, I know they have given the statement here, but we will try to understand. So write the following statement using the symbol of variation. So they have given the wavelength of sound L and frequency F are in inverse variation. Okay. So one question for you all. Have you learned about sound wave or light wave in your science book? Yes or no? Can you please write in the chat box? Have you learned about sound wave and light? That's good. Okay. So, so you are familiar with these terms, but I will give you a brief here about any waves. Okay. So generally wave travel in this fashion. There are many number of ways, but we assume that uh, waves is traveling in this. This is called one way, that is sinusoidal. So it travels in sinusoidal fashion. So what is wavelength? Wavelength is the distance between two peaks, okay, or between two troughs. This is called wavelength. Okay, so on on this axis, this is the time, and on y-axis, it is amplitude. Okay, so amplitude is nothing but it is the uh, we can measure it as a we can consider it as a height or anything. Okay, so for particular wavelength, particular wave, what is the height or what is the intensity? So such type of things we can consider as a amplitude. So suppose this is the amplitude, this is the height of one wave. And what is the frequency? Frequency is how many this type of uh, this type of waves, right, in unit time, in particular time. So we can consider as a unit time. Unit time is like second. Okay, so we can take second, minute, whatever we want. So how many? So we can see that. Okay, so time. This is one unit time, right? So this is unit time. We will consider it as a 1 second. So uh, they have given the statement here. So we know that it is inverse variation, but um, as a means if we have the question like, okay, is it inverse or direct? Okay, so we are just trying to question that answer. So suppose in this is unit time, so we will consider two cases. So in one case, it is wave is like this way. Okay, so where wavelength is wavelength is higher, and one we will consider this case where wavelength is smaller. Okay, so we can see the wavelength here, that is L1, and here as L2. Okay, and here frequency as F1, and here frequency as F2. So if L1 is higher, frequency is smaller. We can see here. And L2, when the wavelength is smaller, right, frequency is higher. Frequency increases. So this is the inverse relationship between the wavelength of the sound as well as its frequency. So we can see the frequency is nothing but number of cycles in the unit time. Here, see the number of cycles are less as compared to here, number of cycles are more. So here frequency is higher. So this is the inverse relationship of length into F. So this way, we have established the relationship between the wavelength and frequency. So that's why again I'm telling and I'm telling you guys that how important these inverse variation and direct variation are. So see, this principle of inverse variation we have used in understanding the sound waves. That is another scientific area where people are working and doing a lot of research about the sound waves. So, means you might have heard about, I'm not sure, acoustic levitation. Have you heard about this word? Acoustic levitation. I know this may be something different, just but I am giving you a small example or small things so that in future you may, if you hear these words, you may feel, oh, I know about something about this thing. So what happens? I will give you small. Um, so that's good. we came across this problem. This is sound levitation or acoustic levitation. So acoustic is nothing but branch of sound. As we came across this sound, so just I am giving you the brief about what is meant by sound. So whatever we speak, that it's sound. Okay. So when there is okay, let me take another color. Okay. So suppose these sounds are generated, okay, at here there is a sound source, okay, so it is generating sound, and this is reflected from, this is the wall. This wall can be a small metal, plastic, or anything, okay. So if you have this is as sound generator. The sound generator is, we can take it as small speakers which generate the sound. Okay, so there are, now we learned about the frequency and wavelength and everything, right? If we have the more frequency, more energy, then these waves, okay, I will show you here, these waves travels here, and if it is kept at such a distance that it will again reflect it back and again travel same path. Okay, again it will travel same path again and again. So what will happen, it will create the another wave, means not another wave, but this is a wave which is very stronger here. Okay, so what happens exactly? The sound waves are nothing but the pressure waves. Okay, so if we put some small balls like made of styrofoam, it's very small balls. If we keep here, if you keep this ball here, it will not fall down. Okay, generally this ball should fall down, but it will not fall down. So this is called acoustic levitation. So if we see here, we will see that it's like magic, that how this is floating here, or this phenomena is called levitating. Okay, it is not fall down. So if you stop this sound generation, then it will fall down and ball will come here. Okay, so this way, this acoustic levitation works. Hopefully, I have given you the brief idea. So these are the used in different applications. But I'm not going into the details. But these are really nice phenomena. You can learn in future, or if you have time, you can read the books also. But this is a really good scientific phenomena. So yeah, we came across this sound wave, so I just wanted to tell you guys, and that is a really good branch in science where people are working and using this sound for different applications. Anyway, we will move. So just I wanted to tell you that how important that whatever we are learning here, it will be useful in future applications. So uh, let's see. Next problem is like intensity of light varies inversely to the square of distance of the screen from the lamp. So light, we know the light. So light intensity is I, and it is inversely proportional to D. Okay, so intensity of light varies inversely proportional to the square of distance. So what example we can think of here is like sorry, uh, we know the sun, right? Sorry, I'm not good in drawing, but I will try a little of my best. So this is sun. Okay, so light intensity. So we know the planets, right? So there is Earth, and there is another, here is Mars, then Saturn, Jupiter, all other planets are there, right? So this light intensity on Earth is higher as compared to Mars, right? So as distance increases, this light intensity reduces. So this is the one example which we can think of right now for the inverse variation. Okay, so let's move forward. So here is another example they have given, like x is inversely proportional to root of y. I think we have covered such type of problem in earlier example. And x varies inversely as y. If x is 15 and y is 10, then if x 20, then y. So can you solve this problem? Can you write down the answer? So x is inversely proportional to y. So x is equal to k by y. So x is 15, then y is 10. So constant becomes 150. So what is the y? So x is 20. So you can put it in the equation. So y is, what is the answer for y? Can you write in the, can you please write it in the chat box? So it will become 150 divided by 20. So what is the answer? Please write down the answer. 150 divided by 20. I think it is easy. I try to make it easy for you guys. So it is 7.5. Okay. So answer is 7.5. Okay. So let's move to the next problems. So time, work, speed. So examples related to number of workers and time taken to finish the work are of inverse variation. Similarly, there are some examples related to time taken to cover a distance by a vehicle and its uniform speed. Such examples variation are the examples related to time, work, and speed. So what this para is describing is like there are examples related to number of workers. Just now हमने अभी देखा कि जैसे number of workers होते हैं और उनको कितना time लगता है एक project complete करने के लिए. तो this is classic example of inverse variation. Similarly, अगर कोई car at uniform speed चल रही है या वो speed vary कर रही है, so टू कवर द डिस्टेंस, तो हमें एक डिस्टेंस कवर करना है, तो उसके लिए भी हम इनवर्स वेरिएशन यूज करते हैं. ओके, सो उन्होंने एक एग्जांपल दिए हैं, तो लेट्स ट्राई टू सी द एग्जांपल्स. So 15 women finished the work of harvesting a groundnut crop in 8 days. Find the number of women if the same job is to be completed in 6 days. ओके, सो यहाँ हमें क्या देखना है कि 15 वुमेन फिनिशेस वन वर्क, सो वो 8 डेज में कंप्लीट करते हैं। तो सिमिलर काम, सेम प्रोजेक्ट अगर हमें 6 डेज में कंप्लीट करना है, तो हाउ मेनी वुमेन आर रिक्वायर्ड। ओके, सो हम इनके लिए कुछ वेरिएबल लेते हैं। So see that let the number of days be D and number of women to be N. So number of days is inversely proportional to 1 by N. So D is inversely proportional to number of women. So D into N becomes K. So यहाँ कांस्टेंट ऑफ वेरिएशन निकालने के लिए उन्होंने कुछ वैल्यूज दिए हैं। सो जैसे n इज 15, सो नंबर ऑफ वुमेन अगर 15 है तो नंबर ऑफ डेज रिक्वायर्ड आर 8। सो हम यहाँ कांस्टेंट फाइंड आउट कर सकते हैं, जैसे d इंटू एन 15 into 8 is equal to 120. 120 is constant of variation here. So now they have asked for the let us find n when d is equal to n 8. Sorry. I think here it should be a 6. Okay. Uh, there is some printing mistake, I feel. Sorry. I'm sorry. Okay. So I feel there is some printing mistake. यहाँ D is equal to 6 होना चाहिए, because they have asked for the 6 days. So if we put the value as a D is equal to 6 here, so we know that 6 into n is equal to 120. So n becomes 20. So 20 women should be employed to finish the work in 6 days. So this is one example where they have utilized the inverse variation principle for carrying out means calculating the number of women or number of days for the certain projects. Another very good classic example is vehicle, right? Which we are more familiar. Okay. Okay. So vehicle running at speed of 48 kilometer per hour takes 6 hours to complete the journey. Okay. How much time will be taken to complete the journey if its speed is 72 kilometer per hour? सो जनरली हम इस प्रकार के प्रॉब्लम यूज करते हैं कि 48 किलोमीटर पर आवर और 72 किलोमीटर पर आवर व्हीकल्स की स्पीड, या ट्रेन की स्पीड भी इसमें जान सकते हैं। जैसे suppose Mumbai to Delhi is the same distance, and if we want to travel it by a certain speed, and if we increase the speed, then how much hours we can reduce. So इस प्रकार से हमें अगर ट्रेन की स्पीड बढ़ानी है, so हम कितना टाइम सेव कर सकते हैं, या if we want to go from Earth to Mars, so what speed should take and how much time it require, right? So it will not be in hours, it will be in days or months. But that calculation is required, and we as a project planning or as a scientist, we utilize this inverse variation principle for different applications. So here we will try to calculate about simple problem of vehicle running at a speed of 48 kilometer per hour. So let's assume that speed of vehicle is s and time taken is t. So there is inverse relations. We know s is proportional to 1 by t. So s into t is equal to k. So k is equal to s into t. We know the values for s is 48 and t is 6. So constant of variation becomes 288. So they have asked us find the t when the s is 72. So we will replace this s is equal to 72 into the equation. S into t is 288 is our equation. So if we put S at 72, and then we can find out T. So T becomes 4. So T is 4 hours. Okay. So we can see that as speed has increased, right? So first speed was 48, then T was 6. As speed is increased to 72, time is reduced. So this way, inverse variation has been used for this type of problem. So let's move to the next practice set. Okay, so we will try to solve some problems. Which of the following statements are of the inverse variation? Okay, so number of workers on a job and time taken by them to complete the job. So can you tell me this is inverse variation or not? Can you type in the chat box? Yes or no? So number of workers is n and time taken by them to complete a job. Is this a example of inverse variation? So sometimes it is it's important. ये important भी होता है कि ये problem inverse variation है या direct variation है. ये हमें समझ के उसके अनुसार formulation करना, that is also another important step. So यहाँ देख सकते हैं कि number of workers on the job and time taken by them to complete a job. Okay, so ये inverse variation में है. Okay, that's correct. So number of pipes of same size to fill a tank and the time taken by them to fill a tank. ये इनवर्स वेरिएशन का प्रॉब्लम है या नहीं है? So एक टैंक है, उसमें हम नंबर ऑफ पाइप्स टू फिल द टैंक, जैसे एक पाइप यूज करेंगे और सब सेम साइज वाले हैं, या दो पाइप यूज करेंगे. दिस इज नंबर ऑफ पाइप्स. सो इज दिस इनवर्स प्रॉब्लम or not? Can you write in the chat box? Yes, that's correct. This is the inverse problem. So generally हम कैसे जान सकते हैं कि whether it is inverse or not. So जो भी quantity दी गई है और जो भी variable दिया गया है, try to change the number and try to think, right? So जैसे कि अभी दिया गया था number of pipes, okay, और time taken to fill the tank. So suppose हम कुछ भी एक जान लेते हैं, मतलब कुछ भी एक वैल्यूज लेते हैं, जैसे number of pipes are 1 and एक टैंक फिल करने के लिए 1 घंटा लगता है, राइट? ऐसा हम एज्यूम कर लेते हैं. अगर मैं नंबर ऑफ पाइप्स को इंक्रीज कर देता हूँ, सॉरी, नंबर ऑफ पाइप आई एम गोइंग टू इंक्रीज टू 2, सो टाइम क्या होगा? बढ़ेगा या कम होगा? सो टाइम विल रिड्यूस, राइट? अगर हम नंबर ऑफ पाइप्स बढ़ाते हैं तो एक टैंक को फिल करने के लिए, दिस इज जनरल कॉमन सेंस वी आर यूजिंग फॉर अंडरस्टैंडिंग सच टाइप ऑफ प्रॉब्लम्स. सो हमारा टाइम रिड्यूस होगा, कितना होगा हमें पता नहीं, बट या वी कैन एज्यूम, मतलब हम समझ सकते हैं कि टाइम कम हो रहा है. अगर एक क्वांटिटी बढ़ाने से दूसरी क्वांटिटी कम हो रही है तो दिस इज एग्जांपल ऑफ इनवर्स वेरिएशन. सो let's see that petrol filled in the tank of a vehicle and its cost. Is this an inverse problem? Okay, petrol filled in the tank. Suppose we will take it as L and cost as C. So हमने 1 लीटर भरा और उसका कॉस्ट है लाइक 100 रुपीज. अगर हम इसकी क्वांटिटी बढ़ा के 2 लीटर कर देते हैं तो क्या क्वांटिटी कम होगी? नहीं, राइट? इट विल इंक्रीज. So this is not the case of inverse variation. So area of circle and its radius, is this inverse variation? Okay. Now can you write the reason why area of circle and its radius is not an inverse variation? Can you write in the chat box, please? Area of circle and its radius is not in direct, sorry, not an inverse variation problem. So why? Can you write it in the chat box, please? Why area of circle and its radius is not inverse variation? It's very, I need like one sentence answer, not write too much. I don't want that. So what is the reason why area of circle and its radius is not an inverse variation? That's correct. Yeah, that's correct. So whenever you increase radius, area of circle is also increases, right? That's the reason we are not, means this is not the example of inverse variation. ये inverse variation का problem नहीं है. Let's try to solve some problems. If 15 workers can build a wall in 48 hours, how many workers will be required to do the same work in 30 hours? Okay, so हमें पता है कि this is inverse variation का problem है. So we will take, yeah, thank you for answer. I can see that answer is like area space. So if area is increases, radius, then radius also increases. Yeah, that's correct. So yeah, so we'll move forward and we'll see that. Okay, number of workers we will take it as n, and time is t. Okay, so we know the inverse relation, n is proportional to 1 by t. So if we use 15, then how much time is required? 48 hours, right? So n into t is equal, it will give us constant of variation, that is 15 into 48. So what is the constant of variation? Can you write in the chat box? Fifteen into 48. So constant of variation becomes 720. So they have asked us, then what will be the, how many number of workers required to complete the same work in 30 hours? So if we put these values into this equation, n into t is equal to 720. So we know the t is here is 30, and if we calculate, n is equal to 24. That's correct. So this way we can formulate and carry out the calculations for such type of problems. Okay, so let's try with 120 bags of half-liter milk can be filled by a machine within 3 minutes. Find the time to fill such 1800 bags. Okay, so there are 120 bags of half a liter milk can be filled by a machine within 3 minutes. So we know the time and number of bags. Okay, again we will keep the same thing. So we will T into N is equal to constant of variation. Here T is 3 minutes into 120 bags. So K becomes constant of variation. So 360. So constant of variation is 360, right? So now we need 1800 bags, right? Sorry, I think so. If we carry out in the same way, then we will get the answer. Am I going the right way? Is this a problem of inverse variation or direct variation? So what are the formulation I am doing is right? Yeah, so this is a different thing, right? I thought that you will notice. So yeah. Anyway, so if T is the time here and number of bags, then here it becomes K divided by N, right? No. So this was the problem for inverse variation. That's what we are using till now. But this is problem of direct variation. Okay. So here T is the time required to means time required by machine, and N is number of bags. Okay. So first given is 3K into 120. So if we use K becomes 3 by 120. I will keep that. It is no, not a problem. And if we try to put the number of bags is equal to 1800. Okay. So what is the T? T is become K into N, whereas K into K, we know the K. So we know the K as 3 by 120 into 1800, right? So what is the answer? That's correct. So T becomes 45 minutes. Okay. So answer is 45 minutes. So we can see that if number of bags is increasing, number of time required for filling up those bags will also increase. So this is an example of direct variation. So whenever you read the problem, you have to understand, you have to see that whether this is a inverse or direct variation. Then only you can go for further formulation. So I tried to make a small mistake here, but I thought that you will notice. But always keep looking for my mistakes also. That's what I want. Uh, if I am going wrong, you can mention in the chat box also. Okay, so let's go to the next problem. So car with a speed 60 km/h takes 8 hours to travel some distance. what should be increased in the speed if the same distance to be covered in 7.5 hours? Okay, so let's try to formulate this. So speed is, we can okay, let me okay, so we will take car speed as s and time taken as t. So we know that this is a inverse variation problem. So we will try to calculate constant of variation here. So S is 60 and T is 8 hours. So K is, what is the constant of variation? Is 480. Okay. And then the problem, in the problem it has been asked to calculate the speed. हमें speed calculate करना है जहां time होगा 7.5 hours. Okay, so if we use s into 7.5 is equal to 480. Okay, so what is s? Can you write in the chat box what is the answer for speed? So it becomes 480 divided by 7.5. So what is the answer? Can you write in the chat box? So answer is 64. No, this is answer is not here. Speed is 64. Okay. Yes, in the question they have asked about what should be the increase. So 64 minus 60 becomes 4. So यहाँ speed जो है वो 64 होगा, right? Or increase in speed, because they have asked about increase in speed. So increase in speed क्या होगा? 64 minus 60. So that is 4. So यहाँ आंसर 64 किलोमीटर पर आवर. सो यहाँ मैं जस्ट आपको एक बताना चाहूंगा, जैसे आप देख सकते हैं कि स्पीड स्पीड का यूनिट क्या है? किलोमीटर पर आवर. और टाइम का यूनिट क्या है? आवर. सो अगर हमने ये कैलकुलेशन किया है तो हमारा जो कांस्टेंट है, कांस्टेंट ऑफ वेरिएशन, उसका यूनिट क्या है? किलोमीटर. ओके, सो जनरली अगर हम ऐसे कुछ यूज करते हैं तो उसका कांस्टेंट ऑफ वेरिएशन का एक यूनिट भी आ जाता है कभी कभी. ओके, इट इज नॉट ऑलवेज ट्रू, बट यहाँ हम देख सकते हैं कि हमें हमेशा 480 किलोमीटर इज द डिस्टेंस, ये हमारा हमेशा कांस्टेंट वेरिएशन है, कांस्टेंट ऑफ वेरिएशन है. ओके, सो लेट्स सी व्हाट इज द नेक्स्ट. आई थिंक दिस चैप्टर is finished here. So I think we will take a leave today and we will start from the next chapter, from the next lecture. Till then, have a great evening to you all and take care. Bye bye. See you in the next lecture. Yes, yeah, Diwali is coming. So happy Diwali to all of you. Have a great Diwali. Enjoy, take care. I don't know about tomorrow lecture.